Hey guys, it's Coach Tapman, and today we're going to be talking about inclined planes as a simple machine. So, what is an inclined plane? An inclined plane, also known as a ramp, is a flat supporting surface tilted at an angle with one end higher than the other, used as an aid for raising or lowering a load. You guys have used ramps or inclined planes before. They just make it easier to move something up. That's really all it is. And so, here you see this this picture of what looks to be a representation of the Egyptians moving blocks for the pyramid, and certainly it would be much more difficult to just lift up a block and move it the full distance that it needs to be moved to be in the correct position, whereas instead you can use a ramp and you can distribute that movement in the Y direction over a larger span that doesn't require as much capability in your workers or your employees or whatever it would be. I don't know that you would consider the Egyptians moving the blocks as employees, but if you did. You also see here on the right side you have a load and you have a force, and so this is how inclined planes are used. You have some load or box or weight or whatever it is, and you're just applying a force to move it up the ramp over some distance. So then for the mechanical advantage of a ramp, it's fairly straightforward. You are just going to be dividing the length of your ramp by the height of your ramp. And that is going to be how you calculate your ideal mechanical advantage. Now we're going to look at an example of the mechanical advantage of an inclined plane. A ramp connected to a loading dock has a mechanical advantage of 3.3. How long is the ramp if the height of the loading dock is 1.6 meters? Well, we know from our equations that the ideal mechanical advantage of an inclined plane is the length over the height of the plane. We also are given in our problem that the ideal mechanical advantage is equal to 3.3, and that the height of the loading dock is equal to 1.6 meters. So now we just use those that equation as well as our value given in the statement to calculate our solution. So our length then is going to be equal to our ideal mechanical advantage times our height, which I'll give you guys a second to calculate, is 5.28 meters. You could certainly use an example like this to calculate how long you need to make a loading dock given a required mechanical advantage, if you maybe knew how heavy the boxes are that you were pushing up the ramp every time that you used it. Very simple, but very useful.